Hello everyone, my name is Fernando and welcome to our Operation Research Final Project presentation. Today we will talk to our complete quantitative analysis for Salas Americanas, including the decision models, production optimization, transportation analysis, and project scheduling. Our objective was to use operation research tools to help Massa maximize profits, reduce transportation costs, and identify the most efficient production schedule.
Hi, my name is Miguel Tuexin. I'm going to tell you about the agenda of this project. Our presentation is divided into four sections: the market information and decision modeling, units production using the simplex method, units allocation using the transportation model, and units scheduling using CPM and project crashing. We will finish with conclusions and managerial recommendations.
Let's continue with a company overview. Masa manufactures three living room models in four plants: Acambaro, Comonfort, Ocampo, and San Luis de la Paz. These units are sold in three main cities: Mexico City, Guadalajara, and Monterrey. The company operates with limited cutting, assembly, and detailing capacity in each plant. The company operates with limited cutting, assembly, and detailing capacity in each plant. It also uses medium duty trucks to distribute units nationwide at a cost of 10 pesos per kilometer and a loading capacity of 2 units per truck. All decisions in this project must respect plant capacities, city demand percentage, transportation cost constraints, processing times, and their predecessors. For this reason, operation research techniques are required.
Now, to determine which type of furniture Masa should focus on selling, we applied weighted expected payoff model. First, we build a payoff table. We use profits per furniture type in each city, starting with dining room, bedroom, and living room. After that, for Ciudad de Mexico, Guadalajara, and Monterrey. Mm, we apply the demand probabilities. We use historical demand data with Mexico, Ciudad de Mexico 30%, Guadalajara 50%, Monterrey 20%. Uh, Once we finish that, we calculate expected payoff. For each furniture type, we use the expected payoff equal to profit city cross probability of city. We compare results with the dining room of 4,750, the bedroom 4,950, living room 5,050, the highest 5,050, the highest, yeah. And the final decision was that Masa should sell living rooms because they offer the highest weighted return, and with this Masa maximizes revenue by prioritizing this product category.
Our next step was to solve the production planning problem using linear programming and the simplex method via Excel solver. The objective was maximize total monthly profit from all plants. Decision variables was Anaheim model, Burbank model, and also the Cedar model. The constraints was cutting hours, assembly hours, and detailing hours. The way we solved it was the first step to resource composition table for each plant. The second was multiply units produced per hours required to compute total hours. The third one was ensure hours used less than hours available. And the fourth step was set profit unit per units produced equal a total profit. The solver configuration was simple. First, we need to set objective cell to maximize total profit, changing variables, units produced for each plant, add constraints for cutting, assembly, and detailing. And the last was select simple LP method to make the solver return the optimal results shown on the next slide.
Now, units production simplex results. After running solver, we obtain the following optimal production quantities: Acambaro 75 units, Comfort 75 units, Ocampo 87 units, and San Luis 85 units. In total, 322 units per month. How we validated the solution. Each plant exactly used but did not exceed its available capacities. For example, Acambaro used exactly 100 cutting hours, 150 assembly, and 200 detailing, and Comonfort similarly met its limits, and Ocampo and San Luis also hit their exact capacities. Now the profit results. Total monthly profit 1,610,000 pesos, broken down as Acambaro 375,000, Comonfort 375,000, Ocampo 435,000, and San Luis 425,000. This solution is mathematically optimal. No other combination gives a higher total profit.
Now let's continue with the units allocation transportation model. We then built a transportation model to minimize monthly shipping costs. For step 1, we compute distances. We use the distance matrix provided kilometer from each plant to each city. The second step was to convert distance to cost. Cost equals to distance times 10 pesos per kilometer times number of trucks. The next step, step 3, we determine supply and demand. Supply equals to units produced in each plant. Demand equals to 322 units times city demand percentage. 49 units to City Mex, 82 units to Guadalajara, and 33 units to Monterrey. The step 4 was to convert units to truckloads. Each truck carries 2 units, so truckloads equals to units divided by 2. The next step, we use solver matrix. We create a cost matrix and shipping quantity matrix. Then, our solver objective is to minimize total shipping cost. The constraints are ship exactly planned supply, meet each city's demand, no negative values, integer shipments where needed, and solver found the optimal shipping plan.
The optimal now the units allocation transportation. The optimal shipping plan produced the following results. Acámbaro, Ciudad de México, 38 truckloads. Comonfort, Ciudad de México, 1 truckload. Comonfort, Guadalajara, 38 truckloads. Ocampo, Guadalajara, 44 truckloads. San Luis, Ciudad de México, 10 truckloads. San Luis, Monterrey, 33 truckloads. The objective value was the minimum possible monthly transportation cost is 5,000, 6,200, 630 pesos. How we confirm optimally? Well, all supply from plants was used exactly. All city demands were satisfied perfectly, and no alternative feasible solution had a lower cost. This ensures Massa ships units at the absolute minimum monthly cost.
The project scheduling was a complete activity list with the task sequence, activity durations, working units involved. The step one was build the activity network. We used precedence relationships to to draw the CMP diagram. Activities include cutting, assembly, detailing, and packaging. Task 2A through H. The step 2 was forward pass. We calculate early start, ES, and early finish EF for each task. The step 3 was backward pass. We compute the late start and the late finish. And the step 4 was identify the critical path. The longest duration path had a total of 23 hours. The slack was non-critical activities display slack values greater than zero, confirming accuracy, and this gave us the baseline project duration.
To explore ways to reduce completion time, we performed a crashing analysis. Step 1, collect crash data. Each activity had a normal time, crash time, normal cost, and crash cost. Step 2. Compute cost slope. Cost slope is crash equals crash cost minus normal cost divided by normal time minus crash time. This gives the cost per hour saved. Step 3. Crash the critical path. We reduced activities in order of lowest cost slope, ensuring the activity was on the critical path, and crashing actually reduced project duration. Step 4. Repeat until reaching optimum. We continued crashing until the project could not be shortened further or costs became unjustifiable.
Now, here we have a little summary of our final results. The normal duration equals to 23 hours, crash duration equals to 14 hours, total crash cost equals to 2,100, and normal cost equals to 1,180. This allows MASA to compare time versus cost trade-offs.
Now we talk about the conclusions. And to conclude our analysis, uh, first we make a market decision, which is living rooms offer the highest expected payoff by 5,050. So Masa should prioritize producing this model. For product optimization, we found out using simplex method, we found the optimal monthly production is 322 units, generating 1.61 million pesos in profit. And for the transportation model, the most efficient distribution plan costs 5,602 and 630 pesos per month, uh, meeting all plan meeting all plan the city requirements. For project scheduling, the normal project duration was 23 hours, and crashing duration 14 hours. So Masa can choose between saving time or reducing costs. Overall, operation research provides Masa with a clear strategy to maximize profit, minimize the cost, and improve productivity. Well, thank you for watching our presentation. We hope this analysis shows our quantitative model's decision, how strength Masa operational performance, and if you have any questions, we will be happy to answer them.